stream. I'm gonna click the button to start streaming, and then it's now loading. Setting up. Okay, now we have. I'm gonna click the button to start streaming, and then okay. So apparently it records already when I say that thing. So I didn't know that before. So okay, so with that experiment done, let's start the third session of today. Welcome, Michal.
Okay. Yeah, so my name is Michal, and I'm here to tell you about a secret project that I have been working on for the last couple of years. Or maybe it's not such a big secret after all, because you may remember, or some of you may remember, that at the last summer school in South Africa, I was showing a kind of an early prototype of an interactive rule-based phrasebook that I was working on at that time. So today I'm here to tell you what that project has evolved into. And I'm here to introduce you to CheckSlater. CheckSlater is a translation app which translates phrases and sentences from English into Czech. And the one thing that makes CheckSlater different from other translation machines you may have seen is that CheckSlater gives you production quality translations, right? So you can use CheckSlater to say something in Czech even if you don't speak Czech or don't speak it very well. And you can be safe in the knowledge that the translation you're getting is grammatically correct and semantically faithful to your intended meaning and pragmatically appropriate to your intended context and so on.
Sorry to interrupt, but like, have you changed slide? Because we're not seeing the full screen mode. It's just your presentation program.
I see. Okay, I'll stop sharing and start sharing again.
Yeah. I think you might need to start the presentation and then share just that window.
Yeah, that's what I did, but
okay.
I don't see that particular window. So I'll just share my entire desktop and
yeah,
okay.
Yes, now I see the full slide.
Okay, that was the title slide. Then there was a dramatic transition to this slide. So I want to tell you that CheckSlater is able to do this, to give you production quality translations, because it isn't a statistical or neural machine translator like other tools you may know, such as Google Translate, but instead CheckSlater is based on a pretty large number of human translated sentence templates, which are then populated and expanded on by relatively simple rule-based algorithms. And some of the machinery behind CheckSlater has been implemented in GF, and I'll talk about that later. But now I just want to take you on a short guided tour through the user interface, right? So let's have a bit of a demo. So let's say you come into CheckSlater and you start typing a sentence you have in your mind, a sentence or a phrase which you want to express in Czech. And as you start typing, CheckSlater will start making suggestions to you for sentences which it knows it can translate. So hopefully the sentence you're looking for will be there, or something close enough to it will be there. So we can click on that and select it and go to that sentence. Currently, there are about 18,000 sentences of English in CheckSlater with Czech translations. But you need to understand that what I'm showing you today is basically just work in progress. CheckSlater is still in development, and what you're looking at is a public beta, which has only been released recently. Eventually, I expect that CheckSlater will have something in the range of 50,000 sentences. Or thereabouts, and I would like CheckSlater to cover all the, let's say, the common situations and topics that come about in ordinary daily life, right? Things like greetings and introductions, and talking about your personal background, and asking people where they are from and what they do for a living, and asking informative questions like where is the bus stop and things like that. Going into shops, shopping, paying for things like that. So the kind of language that you would find in a typical tourist phrasebook, and also the kind of language that you would find in a typical language textbook for, let's say, beginners or lower intermediate learners, right? So CheckSlater is inspired by phrasebooks, right? Phrasebooks are a very old genre, and for most of their history, phrasebooks existed on paper. But paper, in my opinion, is a very poor medium for a phrasebook because, you know, there is almost no interactivity. As Karel said in a comment earlier this week, paper has very, very bad UX, right? Very bad user experience. In a paper phrasebook, you can't really customize the sentences. They're just static pieces of text. With CheckSlater, I want to sort of take phrasebooks to the next evolutionary step. And I want to avail of the digital medium, avail of the sort of the possibilities that the digital medium offers. So in CheckSlater, you can customize the sentences, right? Most sentences have these sort of clickable hotspots in them. You can click on them, then you can sort of select something else and you can customize the sentence like that. A couple more examples. You know, you can change from cats to dogs. You can change numbers. Here's another example. You can change, you know, the day of the week. You can change between today, yesterday, tomorrow, and so on. Notice how sometimes it's not just the one word that changes, but other words in the sentence change accordingly too, right? Because there is a grammar behind all of this. More about that later. You can sort of change the name of the language that you're talking about. You can select from a list of country names. And so many of the things that are kind of changeable in CheckSlater are sort of entities which naturally organize themselves into like lists, all right? Names of languages, names of countries, days of the week, numbers, and so on. But many other things are sort of pronouns, personal pronouns. In most of the sentences in CheckSlater, the personal pronouns are clickable, and you can click on them and you can change from, let's say, I need more money to we need more money, right? You can change from he will be back to she will be back or they will be back and so on. I mean, paper phrasebooks don't give you that, all right? And most of the sort of phrasebook apps that you're going to find in app stores and places like that, they don't really give you that either. Most of the phrasebook apps that I've seen, I've seen many, they're basically just like digital surrogates of static content we've always had on paper, right? So I had always wondered why hadn't anybody built a properly interactive phrasebook yet, until I started building one myself, and this is it, right? But of course, everything stands on sort of on work that has been done before, and we all stand on the shoulders of giants. So CheckSlater really evolves out of other kind of related ideas that have been brewing, especially in the GF community in the last number of years, you know, including the Swedish Ambulance app and Laurette's medical app in South Africa and my own Phrasomatic many years ago, and so on. So with CheckSlater, I'm hoping to take these ideas to the next level and to build something which is really broadly useful, right? Not something which is only limited to a narrow domain, something which has a very, very large number of sentences in it, properly usable, useful search engine, a nice user experience, and things like that. So back to the demo anyway. Yeah, so the interesting thing is now what happens when you ask CheckSlater to translate something which is ambiguous, right? By ambiguous, I mean something is ambiguous if it has more than one possible translation, depending on what exactly you meant. So there are different kinds of ambiguity that CheckSlater is able to handle, and I'm going to take you through them. A lot of ambiguity happens when you translate pronouns into Czech, from English into Czech, or indeed from English into almost any, at least European language, right? Because most European languages have a richer, more detailed system of personal pronouns than English. In Czech, you have things like gender agreement and registers of formality, which are kind of baked into personal pronouns, and other things in the sentence have to agree with them grammatically. And this means that you often run into situations where when you're translating in something from English into Czech, you need to kind of supply additional information which is not present in the English text. But in order to come up with a correct Czech translation, you have to make certain decisions, for example, whether the subject is masculine or feminine, and so on. So a very typical example is any sentence that contains the pronoun you, right, in English, because in English, you doesn't distinguish between singular and plural, whereas Czech does. So what CheckSlater does is that every time you have you in the sentence, it asks you which one you meant, whether you mean the singular reading or the plural reading, right? And you can change between them using these these links, these buttons, right? Now the story is a little bit more complicated in Czech, because in Czech, the second person pronoun in the singular, it encodes not only grammatical number but also register of formality, right? There are two options. Either you're in what I call the T register, which is for informal and familiar speech, or either that, or you're in the V register, which is for formal, so for addressing people respectfully in formal contexts and so on. Of course, you know that many European languages have this distinction, right? And Czech is one of them. In Czech, the V register, the polite you, the pronoun is actually identical with the plural you, all right? So there are two options in Czech. Either you're addressing a single person in the T register informally, or you're addressing either a single person respectfully or a multitude of people. So that's the second option. So that's why CheckSlater always gives you these two options, and it tries to kind of explain to you what the difference is by having these kind of short textual descriptions and these kind of iconic pictures, right? Now, this is a point of, I think, pretty significant difference between CheckSlater and any other kind of statistical machine translator, because statistical machine translators usually don't even know that there is a potential ambiguity, right? They don't even know that. They just give you whichever translation is most strongly supported by the training data. But CheckSlater is different, right? CheckSlater always asks you these follow-up questions if there is an ambiguity. Another area where ambiguity often arises in translation from English into Czech is when you're dealing with gender, grammatical gender, right? Well, actual gender also, right? So like in many European languages, in Czech, you have this situation where the names of many occupations come in gender pairs, you know, words like teacher, student, bus driver, cleaner, and so on. So there's one word for male people having this occupation and another one for female people having this occupation. And again, when that happens, CheckSlater always asks you which one you meant, right? Said by a man, said by a woman. Gender things or gender stuff is quite widespread in Czech, and it's all over the grammar, and it systematically creates gender pairs in many other word classes besides some nouns. For example, in adjectives. So every time you have an adjective in the predicative position, it has to agree with the subject, and then the subject has some sort of gender baked into it, so it has to agree with it in gender as well. And the result is that every time you want to say a sentence like this, you have to decide whether you're saying it as a man or as a woman, right? I as a man am smart, and I as a woman am smart. So again, CheckSlater always asks you which one you meant, so that you don't accidentally ridicule yourself by speaking about yourself as if you're the other gender, right? This affects verbs also, or more specifically, the past participles of verbs. So every time in Czech you put a sentence in the past tense, you have to reveal the gender of the subject. So again, CheckSlater knows all of these things, and it always asks you, right? Of course, this can happen in more than one place in a single sentence. So for example, here's an example of a sentence where there are 2 points of ambiguity, and CheckSlater here is asking you, okay, hold on, what do you mean by I and what do you mean by you, right? So you have two sets of options to choose from. And sometimes you can have all of these kind of variables come together in a single point of ambiguity, and you can have sort of gender, number, and register all come together. And the result is that all the sort of the permutations multiply, and you end up with a fairly long list of options to choose from. So what do you mean by you in this sentence? you know, is it male or female? Is it singular or plural? Is it the T register or the V register? So you have quite a long list of options. And I can imagine that if you show this to somebody who's maybe a monolingual speaker of English, somebody who doesn't really have much awareness of other languages and is maybe not even aware that other languages make such distinctions, that such a person might find a user interface like this a little bit intimidating, and you might argue that that's bad UX, right? Bad user experience. But the point is that, you know, CheckSlater is here not to hide the complexity of the real world from the user, right? So it is a fact of life that the Czech language makes these distinctions. And it is a fact of life that if you're translating a sentence like this into Czech, you have to make these decisions. If you don't, some machine will maybe make them for you, but that's dangerous because you may end up saying something ridiculous or offending somebody or whatever, right? So CheckSlater doesn't hide this complexity from the user, and it always asks you these follow-up questions. So you could say that maybe CheckSlater isn't for everyone, but it is a tool for, I'd say, for the responsible translation user, somebody who cares about production quality translations. Okay, the last type of ambiguity that I would like to mention is lexical ambiguity. Right? By lexical ambiguity, I mean when it's not something systemic like gender or register, but an ambiguity which attaches to just an individual word, which just happens to have two meanings, or more accurately, it happens to have two possible translations into Czech depending on exactly what you meant. So a typical example is the verb to go, the English verb to go, which in many European languages, including Czech, has two different translations depending on whether you mean going as in walking, you know, on your own foot, on your own feet, or whether you mean going as in riding, like taking a vehicle, right, being carried by some vehicle. So in cases of lexical ambiguity like that, CheckSlater always sort of offers you the different choices, the different readings, interpretations, by giving you these tabs at the top of the translation window. Here's another example. There are two words for morning in Czech, depending on exactly which part of the morning you mean. So again, CheckSlater sort of always gives you a choice. CheckSlater knows these things, and it gives you a choice by sort of giving you these tabs at the top of the translation window. Now, there are many types of lexical ambiguity like that in the sentences that CheckSlater has in its database. But I think at this point, I probably need to conclude this part of the presentation where I'm basically just demoing the website or demoing the app like I would to any group of end users. And maybe I need to show you a bit of the machinery behind it, behind the scenes. Okay, so let's have a look at some code. Before I show you any code though, you need to understand that in CheckSlater, all the sentences are pre-generated, so they're kind of static pieces of text as far as CheckSlater is concerned. It's not like there is actually a live grammar behind this sort of parsing and generating in real time. No, it's all the sentences are pre-generated and stored as little pieces of static text. And that's also why I'm able to say how many sentences we have, because all the grammars that generate all these sentences have been deliberately written in such a way that they are relatively flat. They're basically just sentence templates with blanks in them. And there is never any recursion or anything like that. So it is always possible to generate a finite set of sentences from these grammars. So when sentences go into CheckSlater regarding of where they came from, whether they have been generated by grammar or written manually, they come in this format. It's kind of it's a plain text kind of a format with some sort of markup throughout, right? So what you're looking at is something I call a cluster of sentences. And in CheckSlater, a cluster of sentences is a group of sentences where you can switch from one to the other by clicking on selected words inside them, right? Like you've seen in the user interface I've just shown you. So the square brackets are there to tell CheckSlater which words are clickable, and the number of the brackets indicates which words are related to which other words in other sentences inside the same cluster. So all the words that have a single square bracket around them are related, are interchangeable, mutually interchangeable, and the ones that have two brackets are also mutually interchangeable, right? Here is a slightly more complicated example where you have a fairly long cluster, or which sort of contains the sentences, I didn't write that, we didn't write that, you didn't write that, and so on. And almost every sentence here has more than one translation, depending on the gender of the subject, also on the register on the subject in the second person, and the grammatical number of the subject in the second person, and so on. So these tags at the end of the sentences, this is information which tells CheckSlater how to disambiguate this for the end user. So these tags are then translated into these kind of human readable little captions, such as said by a man, said by a woman, or said to someone, a single person you address respectfully, and things like that. Okay, so the first one means first person singular masculine, the second one means first person singular feminine, and so on. So this is the kind of markup that you need to that needs to be present in the data for CheckSlater to be able to kind of ingest this particular cluster and to work with it. All right. This is an example of how we do different kinds of lexical disambiguation, how we deal with lexical ambiguity in CheckSlater. So you can have these kind of labels. So these are basically two different clusters. And CheckSlater knows when there are two clusters where the English sentence is the same, then that's an example of lexical ambiguity, and it presents these little captions to the end user as these kind of tabs, as I was showing you, you know, at the top of the translation window. What else? Yeah, so as you can imagine, I've spent a long time trying to find a good structure, a good formalism for encoding kind of phraseological data like this. And what you're looking at basically it's the phraseological equivalent of a full form morphological lexicon, right? So if you're building a morphological lexicon, you can either have rules for deriving forms, or you can have the actual full forms explicitly listed. So in this particular project, it started from sort of a full form phraseological kind of a dictionary like that. But as you can imagine, writing all of this manually is a lot of donkey work, which nobody likes to do. So I spent a lot of time looking and investigating and experimenting for different ways that I can sort of generate these things automatically. So for example, for each cluster, a cluster like this, I would be able to write just a single entry with some placeholders in it, and then some sort of a rule-based system would generally magically generate all the possible forms for them, for me, and annotate them with these tags at the end that tell me whether it's you singular, you plural, and so on. So that all of this would happen automatically, and at the same time it needs to happen in a way which is reliable and guaranteed to be grammatically correct. So I've experimented with many different sort of architectures and formalisms for doing this until I've kind of settled on a recipe which works well for me, and it's basically composed of two parts. One is a kind of a home-baked system for working with kind of arbitrary phrases that kind of randomly land on my screen, and the other one uses GF for generating sort of more systematically organized collections of sentences. So I'm going to show you the home-baked system first. It looks exactly like this kind of thing that I'm showing here in the box on the right. So what I'm able to do is I'm able to, instead of typing the entire cluster out, every individual sentence, I'm able to type the sentence in only one sort of particular shape, and then mark up the words that are going to be changeable. And so these curly brackets tell me which words are going to be changeable and how they are going to depend on one another. So for example, the first one, the S tells my system that this is the subject of the sentence and it's going to be a pronoun. And then the second one is a verb in the present tense and the lemma for that verb is be, right? And then I have algorithms that kind of read through this and they know that they are allowed to substitute other pronouns besides you for the pronoun and then bring the verb into agreement with that and so on. The same happens on the Czech language side, where, as you can imagine, the grammar is a bit more complicated. So there we have the subject of the sentence marked up, then we have the verb to be marked up, and then we have the adjective marked up. And as I was showing earlier, in Czech, the adjective needs to agree with the subject as well. So it's a changeable word also. And sort of the software that I have written reads through this and converts it into the full form, kind of full form phraseological cluster that I was showing earlier. Here's a slightly more complicated example, which shows the sentence, can I open the window? Can I open the door? And also, can you open the window? Can you open the door? Right? What I sometimes want to do is I don't want these sentence templates to overgenerate. So I need to constrain the variability of pronouns that are allowed to be inserted into them. For example, in a sentence like this, it makes sense to ask somebody, can you open the window? And it makes sense to ask, can I open the window or can we open the window? But it's not really very semantically plausible to say, can he or she or they open the window? So what I've done is I've created this kind of a processing instruction, which optionally can be located at the top of every cluster. And it tells the system which pronouns are allowed to be inserted into the changeable sort of spots. So the numbers 1 and 2 mean that you can insert first person and second person pronouns in there, but the number 3 is not present here. So it means do not insert third person personal pronouns in there. S and P mean singular and plural, and M and F mean masculine and feminine, right? An even more complicated example of this kind of home-baked formalism that I've designed for this project is where you have 2 sets of pronouns in the sentence, some kind of a subject and some sort of an object, like, so do you understand me? Does he understand you? Do we understand them? And so on, right? So there is this processing instruction at the top that tells me that for the subject pronoun, we can insert second and third person. And for the object pronoun, we can insert the first and the third person. Okay, so this will generate sentences such as, do you understand me? Do you understand him? Does he understand us? Does he understand him? But not, do I understand you, right? Because I think that that's semantically implausible and I don't want to have sort of ridiculous, weird sentences like that, because they would then, if people search for something and a sentence like that is suggested to them among the search suggestions, then that would be weird. So I want to filter out sort of semantically implausible sentences away from the data. I'll be showing you earlier how I'm solving a similar problem in GF. Then another kind of example that I'm showing you here is how I deal with sort of varying vocabulary inside the clusters, which are not personal pronouns or things that depend on them. So this is mostly content vocabulary, things like the names of the days of the week and numbers and names of countries and things like that. So here's the sentence: I would like to report a theft, a robbery, a break-in, a murder, right? And this dollar notation is used to kind of insert specific pieces of vocabulary into the sentence. So the software that I have that processes these entries kind of goes through them and sort of multiplies the entries with this vocabulary in them, right? Same for Czech. This is a relatively trivial example where the words that are inserted into the sentences don't change because of any grammar or anything. But then there are situations where they do change. So what what I do, the way that it works in this formalism is that you can actually, in place of these dollar placeholders, you can actually insert entire kind of notation in the grammatical system that I was showing earlier. So you can insert adjectives which are coded like this with these curly brackets, and then the system will know that it needs to bring them into agreement with the subject. Another thing that we are able to do with this formalism is that the individual vocabulary items in these dollar lists, they can have they can have properties, right? So we can use that for example, possessive adjective or possessive pronouns that go with them. So on the Czech hand side, we have a sentence like, I like your hair, I like your face, I like your eyes, right? And then on the Czech side of the, okay, this is a shorter example, but with things highlighted that are relevant for what I'm saying. But then you have the possessive pronoun that goes with each of the Czech words is different between the vocabulary items, because some of the words on this list are masculine, some are feminine, and so on, right? So the possessive pronoun needs to be in agreement with that noun. So here I am kind of inserting, so basically each vocabulary item brings its own possessive pronoun with itself, and it's encoded like this as a property of that particular vocabulary item. Here's an even more complicated example where every item on the vocabulary list has not only just itself as the word or the multi-word expression, but also some properties which question word it comes with and which possessive pronoun it comes with. So this is a fairly complicated example, and it's basically taking the home-baked kind of system that I've developed to its limit. And you're probably asking at this point, why am I not using GF instead of just developing my own kind of my own system? And you know, I initially kind of hesitated, and I thought that it was a good idea not to use GF for this, because I thought that having to write all these sentence templates in GF would be quite a lot of overhead. I thought that I can do it a lot more quickly if I just invent my own kind of notation. And that's true up to a point. But sometimes I reach sort of the limits of what the system is able to express, the limits of expressibility, right? So there are, in some types of sentences, there are grammatical dependencies between all the different words that are so complicated that they are impossible to express in this. It happens rarely, but it happens but it does happen, right? So for that, I've developed a kind of a second alternative approach to generating sentences, which does use GF. And also the benefit of using GF for at least some of these sentences is that I am able to kind of do it with a little bit more kind of less arbitrariness and more kind of systematic approach, where I'm able to kind of look at the whole semantic area and just generate every conceivable sentence that somebody might want to say in that particular area. Whereas in the previous model, where I was just manually editing a lot of sentence templates, I was doing it in a more of a kind of an arbitrary random fashion. I took, for example, a bunch of sentences from like something like a phrasebook or from Tato-Eba, and I sort of edited them manually, right? But if I'm using GF, it allows me to be quite a bit more systematic to in terms of the sentences, in terms of the coverage of particular semantic areas. So I've started building a lot of sort of relatively small and relatively simple application grammars in GF that allow me to generate sentences which can then be sort of which can then, with a little bit of post-processing, can be converted into the formalism, into this fully expanded formalism that CheckSlater expects the data to be in. So here's an example of one. This is an application grammar for generating sentences where people have lost things or found things. Okay, so You can use it to generate sentences such as, I have lost my glasses, and have you lost your passport, and have you found my passport yet, and who lost their passport, and has anybody lost their glasses, and sentences like that. All different permutations of sort of personal pronouns and objects that you can lose and find and so on. So this would be the abstract grammar of that. So you see the list of sentences, you see the list of entities that the grammar thinks people can lose or find. Then further down, you have the actual sentence templates. So these are the templates for sentences like, I have lost my keys, have you lost your keys, I have found your keys, and so on. This is the concrete grammar in English. So see how the linearizations contain these square brackets, right? So this is the markup which CheckSlater requires. So it's not like you can take any application grammar and just have it generate sentences and plug them into CheckSlater. The sentences need to contain this markup in them. This is very important. Another example, this is an application grammar which generates compliments. So nice things you can say about people. For example, oh, I like your hair, or you have such smooth hands, or I like your eyes, and so on, right? So again, this is the application grammar, and here is the list of qualities that you can compliment people on, like things like you're interesting, you're slim, you're tall, you're attractive, you're beautiful, and so on. Then further down, you have the list of entities that you can, you can ascribe these qualities to people, and then you can ascribe these qualities to things possessed by people, such as their hair, their eyes, their hands, right? Things like that. And then at the end here, you have these sort of templates for sentences where you can sort of use this vocabulary, like you have beautiful eyes, am I beautiful, you are so beautiful, I admire your hair, and so on. Sentences like that. In each of these application grammars, I have the abstract grammar, then the concrete grammar in English, which generates English sentences with the markup, with the square brackets, and then a concrete grammar in Czech, which generates the sentences in Czech. And then I have a third application grammar, which doesn't linearize into any specific language, but it linearizes into statements about whether or not this particular sentence is semantically plausible. So this is the grammar you're looking at now, right? So this, for example, is a function which tells me whether one particular combination of quality and entity is semantically plausible. So this is what tells me that it is semantically plausible to say that eyes are beautiful or pretty or lovely or interesting or sexy, but nothing else, right? And it's telling me that when you're talking about hair, it's semantically plausible to say that they are beautiful or pretty or lovely or soft, but nothing else, right? And when you're talking about somebody's smile, you can say that they have an interesting smile, for example. This is sort of evaluated as semantically plausible by this, but not other properties, right? So I use this approach to kind of filter out semantically implausible, weird, strange combinations of vocabulary in the sentences, right? So this is a technique I sort of invented myself at the last summer school in South Africa, where I was kind of worried about this problem of GF application grammars over-generating, say, generating sentences which are grammatically correct but semantically implausible, right? You can read about it. There's a GitHub repository I created years ago where I'm describing the technique. So basically, the way it works is that these statements about the plausibility of the sentences are generated when I'm generating a tree bank from this application grammar. And then I have a simple script which kind of processes the tree bank. It throws out the sentences that are labeled as implausible and keeps the ones that are plausible and organizes them into this cluster formalism that CheckSlater then uses. All right. And this is pretty much everything I wanted to show you as far as the technology behind CheckSlater is concerned. As I was saying, CheckSlater is work in progress. When the project started, I and a couple of other kind of friends that are working with me on this, we started just by manually annotating lots of sentences, and then gradually we started doing a lot kind of more automation. This kind of the scheme with the curly brackets and the dollar sign kind of evolved out of that. And then at some point, I reached a point that I said to myself, all right, that's enough. I need to start using GF for this because it's just too unprincipled, too random, too wild, too difficult to maintain. So now we have a situation where I'd say about 5,000 sentences are generated by GF grammars, and then the remaining maybe 13,000 are generated by the old kind of manual home-baked encoding formalism, right? So CheckSlater is work in progress, and why am I doing this, or why is this happening at all? I mean, I've always been obsessed with the question of how do I make it possible for people to say things in a language they don't speak, right? And obviously, what do people do these days when they want to say something in a language they don't speak? They either go to a machine translator, which doesn't give you production quality translations, so it's a bit dangerous, or they go to something like a dictionary or a phrasebook. And those do give you production quality translations, but they usually have abysmally low coverage, so you can't really find stuff in them that you do want to say. So I thought, can we just take the convenient user experience of a machine translator like Google Translate and combine it with the kind of the reliability and the production quality that you have in phrasebooks, and sort of bring it together into some sort of a new kind of genre of a language reference product, something which combines the best of both worlds. So that's kind of the idea of CheckSlater. I want to kind of conclude this by recycling this slide from Arne's presentation at the beginning of the summer school, where Arne was explaining, as he always does at the start of the summer schools, that when you are doing sort of machine translation from one language to another, you can park yourself either in the high coverage, low precision end of the spectrum where the machine translators are, or you can park yourself at the high precision, low coverage end of the spectrum where GF application grammars are. And I wanted to see if we can stretch that a bit and move the kind of the rule-based high precision mechanism a bit closer to kind of a usable high coverage. So my sort of my mission, my idea for CheckSlater is that we will have, I mean, obviously we will never be able to match people like Google Translate or Bing Translator, which basically are able to translate anything, not always very well, but anything, right? So we can never have that because we will always have only a finite set of sentences. But my idea is that if we take care to include this ballpark figure of 50,000 extremely common sentences, then we will actually have something that where people will find the things that they want to say, you know, like the ordinary everyday sentences that come across in ordinary sort of everyday life. So that's my hypothesis. This is all just an experiment. As I was explaining at the beginning, CheckSlater has been only released recently as a sort of a publicly available beta, so we're not even claiming it's finished or anything like that. It's a question of where this project will go. There's a possibility to maybe turn it into something that we can sell to end users, like mobile apps and things like that, not only in Czech, but also in other languages. Maybe there's a possibility to combine it with other things that we have seen this week. For example, you know, the grammarian tool that Krasimir was showing earlier. I can imagine a kind of an ecosystem where a lot of people are authoring a lot of small application grammars and then sort of plugging them into a tool like CheckSlater. So this is all just an experiment, but I would hope that what CheckSlater is doing is that it's kind of taking an idea that has sort of, as I have said, has existed in the GF community for a long time, to kind of build interactive end user facing language reference tools that kind of are based on rule-based technology. So they kind of, they have production quality content, and at the same time to scale it up to kind of higher, realistically usable coverage. So with that, I'm going to stop talking, and I hope that you will have some inspiring questions or comments or objections at this point. Thanks very much.
Thanks, Michal. Any questions?
I'm looking at the chat now. Dating 101 guide. Okay, yeah, exactly.
Yes, Arianna, you have a question?
Yes, so first, I really like this work. I used to really love phrasebooks when I was younger, and then I was always very frustrated with the limitations of them. And yeah, many of the things that I see here make checks later like sort of the phrasebook I wanted to have at the time.
Yeah, me too.
So this is really, really cool. And so first question is this or part of this open source?
Well, the short answer is no. The longer answer is not yet. I don't know. Because as I was saying, I'm not quite sure whether or not it will be possible to turn this into something that can be sold, right? But then again, I don't know. At this point, it's not okay. But I don't know yet. I mean, basically, what I'm hoping to achieve from this presentation is to kind of fly the kite and to see if there is a strong response from the community, and if people want to use this something like this for their languages, whatever, then maybe we can open source the whole thing. I don't know. And if not, yeah. So. Yeah.
I definitely want to use it. I think like phrasebooks are a lot better when you have to say something in a particular situation, but you also want to learn something. They're a lot better than just automatic translation that doesn't, I mean, like for instance here, if I want to say I am a student, then I know, for instance, that there is another variant of I am a student, which is the feminine, and I learned that one as well. So it's very interesting. Or I can even change student into something else. Like I was trying this while you were presenting, and so here is my other question, which is I noticed that you have a really cool thing, which is if a phrase is not found, then you look for a translation somewhere else.
Yeah, it falls back to machine translation. Yes.
Yes,
but it tells you that this is machine translation.
Yes, and that's I think really good for the moment. And I see that you resort to machine translation, but also I guess if it's single words, to a dictionary, right?
Yeah, there are two fallbacks. If it doesn't find what you're looking for, it looks for a dictionary. It looks in a bilingual dictionary. It uses Panlax for that. I don't know if people know what the Panlax project is. Yeah. And if it doesn't find it there, then it goes into machine translation. It uses the API from Microsoft.
But I'm thinking, what if I am searching for something which is like a known sentence template? Like, for instance, I know that there is a sentence which is like X is a Y, like for instance, student. But then let's say that I'm looking for something like I am a programmer. In that case, how easy would it be to make it so that it looks for the word programmer in the dictionary and tells you, well, this is not machine translation, but the last word is not completely, hasn't been checked, sort of.
That's an interesting idea. Well, that's kind of going towards not having a long list of static pre-generated sentences, but having actually live kind of grammar or something in it. Yeah.
Yeah, that would be like a lot more flexible, I guess. But how easy would that be? Does Panlax have the morphological information it needs, or?
I'll keep that idea for later. In principle, it's doable. Yeah. But I'm not sure how that would sort of work how that would support the search kind of scenario when, yeah, I don't know. Well, yeah, it's a good idea. Yeah. Thank you.
Yeah.
Karel, Laurette, and Arne.
Very nice work. So to me, it seems that there is a strong overlap between language learning apps and this kind of phrase books. And language learning apps seem to be something that get a lot of VC funding recently. I think there are like 3 Estonian startups that do language learning apps. So talking about selling this product to customers, have you considered kind of pivoting, to use a startup term, pivoting this application to language learning, and what kind of impact or changes would be required for the UI and for the underlying technology? Or maybe phrasebook is the future and language learning apps are more the past, where in the future people don't want to learn languages because language technology is so strong already and helps them in communicating, and they only need a phrasebook or this kind of modern phrasebook.
Yeah, well, thank you for mentioning that. I mean, that sort of thing has been at the back of my mind as well. And you're right that there's probably a bit more commercial potential in language learning tools rather than just sort of reference tools. I think that's the audience there is kind of a bit more dedicated, more motivated. And yeah, I'd say people in general are more prepared to pay for language learning tools and not so much for kind of language reference tools where they just look it up, look things up when they need them, right? But so it's so that has been sitting at the back of my mind, yes, but I haven't really spent much brain time on this. But you're right, there's probably a bit more potential there. Then again, I think I need to do this in another target language than just Czech, because Czech doesn't really have such a huge interest from people who are speakers of other languages learning it. I mean, there is some, right? Yeah, but it's not a major learned language like English or Spanish or German or French, right? So for this particular product, for CzechSlater, I was motivated by just having a lot of friends who live in this country, in the Czech Republic, but are not speakers of Czech and are constantly struggling with the language and are always finding it difficult. So those are people who are kind of generally informed about the language. They understand that there are these gender things and these TV things, right? But they don't always know how to say things. So that would be a tool for that kind of a community. But then using the same or similar form of just generating forms of sentences from templates can definitely be used for language learning. And if I have any free time, I will certainly look at that. Yeah, so thank you for reminding me that this is also important.
So I was going to ask two questions, but then from the depths of my memory, I kind of have this feeling that I asked this in Stellenbosch as well. But so my first question is, have you thought about the idea of having kind of multilingual plausibility grammars? So something might be plausible in one language, but not in the target language. So I don't know, something in English makes sense, but not in Czech.
Yeah, if you're someone who kind of habitually lives with more than one language in your head, then every now and then situations happen where something sounds completely normal in one language, but then when you kind of convert it into another, it sounds like really weird, and people don't say that. Like sometimes when people ask me, how do you say this in this other language? And my only answer is they don't say that. Yeah, so yes. Theoretically it can happen. Yeah, I suppose when you have an application grammar, when you're generating comments about compliments about people, right? It may be linguistically / culturally inappropriate to comment on certain things, but appropriate in other cultures. I don't know. I mean, maybe in some cultures it's taboo to talk about people's hair or whatever. You know, maybe long hair is considered beautiful in one country and not in another. I don't know, right? So it's possible, yeah.
Okay.
In the setup that I have, it's only 2 languages, so that's kind of defeats the But obviously, if you wanted to scale this out into many languages, then you would need to do a lot more acrobatics. And actually, when I kind of started thinking about a project like this, it was a lot more multilingual, but then I decided to limit it to only 2 languages and only in one direction, and only with the encoding scenario in mind. So you have a user who is a speaker of the source language, but not a speaker of the target language, right? So I decided that I need to narrow this project down into this, because if I want to do it more multilingually, then the complexity is just so difficult. So but this hopefully would be only the beginning, and hopefully we can scale this out somehow in the future. Yeah.
And so my other question is whether you have done any UX testing with users? Do you have any idea? I mean, I think I like yours much more than ours, but it has very many of the same ideas, these template sentences that you edit certain aspects. Do you have any idea of people what kind of target audience? Have you done tests, or have you just thought about this a bit?
Yeah, the short answer is no. The testing is happening as we speak, because when I said at the beginning of my presentation that it's only been released recently as a public beta, by recently I mean like literally 2 weeks ago. So, and I've collected a mailing list with people who sort of expressed an interest in this earlier, and I kind of politely asked people to kind of have a look at it and provide some sort of feedback and tell me what they think. So far, the feedback has been kind of interesting. Okay, okay, yeah, but nothing hugely positive, nothing hugely negative, right? I mean, it's not like I expected a huge reaction either. I think that this will be kind of a slowly burning fire, and the other part of the question is that we don't really have resources to do any kind of principled, motivated user acceptance testing. So I think that what I want to do, at least for the near future, is just to go with my intuitions about what I think people want and just give it to them, and hopefully I will not have been too wrong, and it will turn out to be sort of useful, and hopefully some people somewhere will find it useful. Yeah.
Well, thanks. Yeah, I really enjoyed your talk. Thanks for that.
Yeah, of course, there are lots of similarities with the thing you're doing with the medical app, which I've downloaded and installed. And
well, I think that makes sense, because we are using many of the same starting ideas. So, yeah.
So the whole user experience of having these clickable sentences is such a new thing that I think that people are kind of. I honestly, I have no idea whether people will warm up to this or not. Right? I don't know. Well, I've done the best I possibly could to complement that with a relatively useful search experience. So you can you don't have to click through like 5-10 screens to find the sentence you're looking for. You can just sort of search for it. And then there are these fallbacks to machine translation and dictionary lookup if you're looking for something that's not there. So I've done the best that I possibly can to kind of supplement this clickable user experience with things people already know, like search. Everybody knows what search is, right? But nobody knows what these clickable placeholders are. So hopefully it's not too alien for people, but I don't know yet. Yeah. So anybody out there wants to conduct some systematic testing of this, I would be very happy to read the results of that. Okay.
Okay, Arne, and then you can look at the chat. Let's have Arne's question first.
Yeah, so thanks, Michal. It was very neat and very inspiring, as always, when you present your new ideas. So 2 questions. So one is that, so when you choose your own gender and the persons that you are talking to, so do you have to do it every time you have an ambiguous phrase, or is it remembered from the previous one, for instance?
The short answer is no, it's not remembered. You have to choose it every time. But obviously, the long answer is that would be that's something that's been on my radar too. That it would be good to remember these things. But I haven't gotten around to doing that yet. One thing that slightly complicates this is that different sentences have ambiguities with different levels of granularity, right? So for one sentence, you may need to decide. You may need to choose between T and V, or between singular and plural. And for other sentences, you may need to decide between singular masculine, singular feminine, and so on. So it's a bit more complicated than simply remembering the choices that the user has made. You also need to understand the choices and maybe break them down into components like gender. So it's an obvious idea, but I haven't done it yet.
Yeah, what I was thinking about is that you have a kind of an environment where you have the gender and number of the speaker and the hearer to start with, and
yes,
and then some of those. But anyway, so then the other one was that I saw the English grammar and you were not using the RGL, so I wonder why, and if you are using it in Czech and for instance for the morphology. And
Yeah, I somehow find it easy enough to not have to navigate the RGL, which I find a bit overcomplicated, to be honest. And I just sort of, in every application grammar, I just encode the things that I need. And I just, to be honest, this is perfectly appropriate. I find that it's easy, right? Yeah, I'm not going to apologize for not using the RGL. I just find that this is perfectly okay like this, and sometimes having to deal with the RGL in very, very simple, tiny sort of single-purpose application grammars like this. For me, it's a bit, it's an overhead which I sort of find it gets in the way. So
certainly, if you have a kind of many-way agreement dependencies in a sentence, then the RGL will give you much for free.
Yeah, there haven't been any sort of hugely complicated scenarios like that yet. So maybe I will change my mind again, like I changed my mind about using GF at all at one point. But yeah.
Okay, thanks. That was my questions.
Yeah.
Okay, let's take the chat questions and then Laurette.
So I'll have a look at the chat. What's dating 101. Can CheckSlater go from Czech into English? No, it's only, again, as I said, it's part of my kind of deliberate constraining of the project to just one language pair in one direction. And doing it in the opposite direction would be, at this point, too complicated. So I didn't do it. And also you get, I think what's happening here is that CheckSlater is interesting when it goes from English into Czech, because it's going from a morphologically relatively simple language to a morphologically relatively complicated language. So you have to do a lot of disambiguation in terms of gender and plurality and register and so on. But if you're going in the opposite direction from Czech into English, then you don't have any of these ambiguities. So the user experience would be a bit different. It would be more like a typical translator where you type something in and you get one translation and that's it, right? So it probably wouldn't be so interesting. I think that the kind of user experience that I was showing here works well for when you're going from English into some other language, or from a morphologically simple language to a morphologically more intricate language. Autocorrect. Not as such, but so there is no plan to have autocorrect or spelling correction. Yeah, that's relatively easy to work in. It's just an engineering problem. But what's the thing that we have there is when you start typing, this suggestion kind of box comes up, and that's supposed to kind of partially fulfill the function of spelling correction or autocorrect, where that box is supposed to sort of suggest to you sentences that are somewhat similar to what you have typed. Did you manage to use root and pattern to generate new words that are adequate for the context of a given translation? Well, no, the whole idea is that this would be highly controlled. So all the vocabulary there has been sort of checked by humans. And so if I understand the question correctly, that's similar to the question as to whether we could have just generic patterns and let people sort of insert their own words into them. And I would be a little skeptical about that. I'd like everything to be sort of 100% sort of seen by humans before it is shown to the end user. But we'll see. Yeah? I don't have a hugely strong opinion about this. Do you manage to? Do you consider interlanguage where translating words that look similar in both considered languages? I'm not sure if I understand that question. Well, English and Czech are not similar, so it's.
No, I'm just talking about words that look similar. For example, for English and French, there are many words that look similar.
Yeah,
not
this
that
happens.
of false friends.
Oh, I see. False friends. Yeah, I'm not dealing with that specifically, but of course there are false friends between English and Czech. So there are kind of things that, let's say if you're an English speaker who is learning Czech or trying to use Czech but not speaking it very well, there are traps you can fall into where there are false friends waiting to beat you down. And so, I mean, CzechSlater kind of handles these things implicitly by giving you the correct translation, right? But we're not doing anything specific to kind of notify the user that they're looking at a situation where there are false friends. It's an interesting idea. I'll keep that. Thank you. This should be mobile. Oh, yeah. Well, there is a. I mean, it's a website. It's not an app, but it's a responsive website. So it looks and works relatively well when you're looking at it on narrow screens and mobile browsers and things like that. Anyway, that's not a language engineering issue. That's more of a kind of a general software engineering issue.
Yeah, let's take Arna's question, and maybe after that we can conclude.
Yeah.
Arna, did you have a comment? Or
sorry, I just didn't lower my hand.
Right.
Sorry.
Yeah. Okay. Yeah. Yeah. My comment, like, I was like, yeah, before you mentioned, like, my first impression was that, yeah, I would use this like I use Tatoreba, and also like I had also thought I would use it as a language learning app, because this is much more like I find that this is actually kind of, compared to many Duolingo courses, like this is more comprehensive, because like often you do something in Duolingo and then you just get a sentence and you don't get an explanation. You maybe have to click on the comments and then you see what other users have explained, like why is it this way, like, oh, this is actually masculine, this is actually feminine. So I think like this would for my purpose, if I wanted to learn Czech, like I would definitely check that out.
Suppose part of the reason why I wanted to do something like this is I was frustrated with how Tatoeba is a very large database of sentences in many different languages, but the sentences in Tatoeba are basically just little pieces of text. They're completely unanalyzed. You don't know whether what you're looking at is the male or female or plural singular, you know. It's such a shame, you know. It would be more useful. I mean, obviously it's not my job to tell the people behind Tatoeba how to organize their project, but I wanted to have a database of phrases, not words, but phrases, full sentences, but annotated in such a way that it's possible for the end user to kind of switch between, you know, masculine, feminine, things like that. So
Alexandre, sorry, I actually said that this would be the last comment, then I started talking. So.
Okay. Yeah, actually, it's interesting that you mentioned Tatoeba, because I had this tentative to also work with their data, but the problem that I faced was not only the problem that you just described, that they for example, they are not they do not put constraints in what people think that text is, right? So people could potentially write as a sentence, actually 2-3 sentences, a piece of text. So when I asked about that, they said that their intention is more about helping people to learn language without these linguistic-oriented thing. But one more serious constraint for me is the fact that they can edit your sentence. So if you add a sentence there, people produce a lot of translations. Then someone can go there, and the maintainers can go there and edit your sentence, change the sentence. So, for example, this notion of what is a grammatical or a grammatical sentence, right? This notion is very fuzzy, right? So for a normal speaker, like one can say that for example, an English speaker that is in the learning process of English would think that a sentence ending with a preposition is not a valid language English, but we know that we can do something like that. One thing is what people suggest as a good practice. Another thing is the grammaticality of the language, and they often try to judge your sentence regarding the naturality of the sentence, how natural it is, how easy it is to read, and they change it. And I think that kind of a block any use of Tatoeba for linguistic-oriented studies, right?
Yeah. Yes, yeah.
Sorry.
Well, when it comes to grammaticality, I suppose the situation is a bit different in Czech because it's a slightly more tightly regimented language where it's a little more less ambiguous whether something is grammatical or not, right? So it's always possible to decide. Then you mentioned at the beginning there that for translating longer pieces of text rather than just individual sentences, I suppose that's one kind of important limitation I should have mentioned, that this is a tool for translating just single sentence things, right? Not longer pieces of text. I mean, you can type anything you want into the search box, and if it's something long, then it won't find it in its own database, so it will fall back to machine translation. And it will translate it for you, but it will be just ordinary machine translation. So,
but just to mention to you, I don't know if you are aware of that. There is one of the maintainers there is a professor in Japan. I think he's an American guy, but that lives in Japan for years. And this guy has a curated list of sentences that he maintains for pairs of language. So there is a website that's not linked in Tatueba anyhow, but I can recover from my emails. And in this website, you can select a pair of language, and then you have a curated set of sentences from Tatueba.
I've seen something like that. Yes, yeah. I've experimented with many different sort of recipes for getting good sentences out of Tatoeba. Yeah. You can filter by things like, is the sentence owned by a native speaker, and then you can sort of do kind of heuristic tests like how long is the sentence and how frequent are the words in this sentence. So yeah, I've seen some lists. I've seen some kind of curated subsets of Tatoeba, maybe even the one that you're mentioning, but my impression was that they're not necessarily totally reliable either. So yeah.
Okay.
Yeah, I'm constantly looking for kind of new ways to speed up and scale up the process of editing and producing these sentences, and we're definitely not there yet. It's still a lot of donkey work, as Arne says. So.
Thank you.
Yeah, okay. Suppose it's time for our next speaker, which is you.
Yeah.
Yes, I was trying to postpone that, right? Making questions.
Yeah. How about let's take a 5-minute break and then we hand it over to Alexandre.
Okay.
So resume 17 past. Okay, it's 17 past. Let's get back to this last talk of the evening. Are you back, Alexandre? Okay, let's wait for the speaker. So
Here I am.
okay, we have a speaker. So so let's hear this talk, which is not about GF, but it's good to broaden our horizons and hear about how do people do in other grammar formalisms. So let's hear about the Portuguese grammar in HPSG.
Okay, so first of all, I'd like to thank you very much for the invitation and for all the work you're doing in the organization. So thank you very much for that. I know that this is kind of a cliche to say that, but I'm really happy to have this opportunity because I'm following this community for a long time, and I missed 2 or 3 opportunities to go to one of those summer schools. In the summer school in South Africa, I sent one of my students, Bruno. He did one of the first works that we were able to do with GF in Portuguese, and I'm very proud of that. I mean, he was a great student. Unfortunately, he just left after graduate, right? That's a common pattern, but it was very pleasant. And the reason for liking so much is I really like all the ideas. I'm a logician as a background, so I work with in other contexts. I work with dependent types, ITPs, and all these things came very close to GF and the foundations of GF, right? So all the work for Hunter, that was a very nice material that I consumed years back and still consume every day and try to understand more. So that's a community that's close in my mind every time. So that's a very happy opportunity for me. So the work that I present here is this Portuguese grammar. And this is a joint work with Leonel. Leonel presented yesterday here his work with GF grammar for Indian language, Brazilian Indian language. And I have to say that Leonel is the main maintainer of that, right? I'm learning a lot of Leonel. So Leonel is a very good friend. He's an unbelievable person in the sense of being always open to teach and to give me all the insights of the linguistics insight that he has in the background. And he's one of the few linguists that are open to have people from other areas collaborate, right? I heard many times from linguists things like, oh, for doing that, you need to be a linguist. Like a sign of stop, right? You are not allowed to do that because you don't have a degree in linguistics. And Leonel is the opposite, right? Leonel is the guy that's keeping saying me that okay, we can do that. I mean, it's all about learning. There are conventions, there are the definitions, and we can learn all of them. And people from different areas can contribute. So I'm very thankful to Leonel to drive this process and help me collaborate with him on that. Leonel is from Federal University of Ceará, and I have 2 hats, right? I'm from IBM research and also from an academia. I still have a position in academia. The EMAP is a school of applied mathematics in FGV. FGV is a kind of foundation in Brazil. It's a kind of university, a non-profit foundation. So previous work that we have on Portuguese grammars. So we have a work done by the University of Lisbon on the LX grammar. The LX grammar is actually a Portuguese grammar in HPSG formalism, but it's not free. And this is is a shame. I mean, the project was very well documented, but the code is open, but the license do not allow you to change or modify anything in the code. So this for me is something unbelievable to have happen, and we cannot even, we have to take even care about looking to the code, right? We can read the documentation, try to have insight, but look into the code, would be a problem, even mainly because of my position at IBM, right? IBM would be very strict on that because anything can derive from that, right? Another system that we have is Palavras. Palavras is based on top of the constraint grammar framework, right? And it's again not open source. In that particular situation, it's not even open source. So we can have the demo online, we can play with the tools online, but we have to pay a fee to download the code to run the code. Actually, in the past, I was able to actually buy a license, FGV, bought a license of Palavras. And then we start to see the problems with not a project that's not open source, right? The code is completely, it's very difficult to maintain. It's not well documented. There are a bunch of Perl scripts combined in different orders. There are many problems in the code, but the main point is not to criticize the code. I mean, every project has those problems, right? We know that we start with a clear idea, then we can keep evolving in the ideas, and it's not always easy to keep that clean and consistent code without too much resource to help. But my main problem is not that. My main problem is because of, again, of the license, right? This blocks a lot of studies that could be made. But and it's funny because many resources in Portuguese done by Brazilians or even from Portugal, right? Use the palavras. So we have a trace of the influence of palavras in many linguistic resources for Portuguese. Many of them derived from a group in Portugal called Linguateca that used to be head by Diana Santos. She's now in Oslo, I think. But she had collaborated a lot with Eric, the author of Palavras, and we see the influence of this resource in, for example, corporas that are annotated with palavras, and then they have the traces of how the tokenization was done and how the part of speaks, the decisions and the syntactic decisions, that all influenced by palavras. And we also have the work from Leonel that used to work with LFG framework, and he has worked for many years in BR-Gram. BR-Gram is also available in our GitHub. We now have a GitHub organization called Language Resource for Portuguese. And inside that organization, we have all the projects. The Porgrams is still private, but we will make it public in this week. I hope I'll talk with Leonel about this. We are just waiting the first article to be published. And we have also the BR-Gram, right? I think that I convinced Leonel to migrate to HPSG, mainly because compared to LFG, what happens with HPSG is that we do have a bunch of tools that are completely open and free available. In the case of LFG grammar, the LFG itself is free, so the license that Leonel chooses is a free license, but the tool for compiling the grammar and use the grammar, the XLA, is a tool that came from Xerox, so it's still proprietary tool. Now it's, I think the code is the code is not maintained actually. From the last years it didn't have too much maintenance on the main code of XLA, but is distributed by a university in Germany, I think. But in fin, it's not completely free. Okay, so the first question is why, right? So why we want to implement a grammar for Portuguese, right? So, and I have many answers for that. For the point of view of Leonel, of course, he works in a graduate program in linguistics department in the Humanities Center. So he teaches courses on linguistic description analysis, so computational linguistics, right? So it's completely, it's his area of research, right? And as he's mentioned yesterday in his talk, we have this linguistic point of view when we implement a grammar, right? We want to study the grammar with formal tools that help to make a hypothesis about the language and test those hypotheses. Like, as any logician knows, or any one that works with ontologies and models, we know that once we start to formulate hypotheses and axioms, at some point of the time, we can start to make contradictions, right? You can start to derive contradictions by your own hypothesis. And we want to find as easy as possible, as soon as possible, those contradictions to correct your hypothesis and refine your model, right? This is the general way to study a domain. And for language, I think the analogy is quite similar, right? We want to study language, formulate hypotheses, and test those hypotheses, and check what are the derivations, what things you can conclude from those hypotheses, and then if these conclusions are things that you expect or not, or could be checked for being valid or not, right? So these formal way to deal with language and models of language is the linguistic point of view. To me, as I said, I have two hats. So at FGV, I'm a professor in mathematics department. So I have to emphasize this connection between mathematics and linguistics. And this, it's not so easy nowadays. The connection is basically with you know, people are using mainly matrix and machine learning, right? So the connection that people see is just statistical courses, probabilistics, and linear algebra and linguistics. People can see this connection. But when we talk about automata, when we talk about grammars, context-free grammar, and those studies of formal grammars, then I try to make these more. I try to bring to the student this broader view, right, between the connection of mathematics, and remember people that mathematics is not about numbers, but as abstractions, abstraction models about the reality, right? And the connection of mathematics and linguistics for me is very important. Of course, this came from the fact that I have this formation in logics, right? So I kind of think on this old school mentality. And having those projects helped me on the courses, right? So I have students that collaborate in our projects. So in all projects that I will show here and comment here are projects that I have students collaborated. And now I'm teaching after more than 10 years working with natural language, now I have the first course on introduction to NLP, and it's kind of interesting to have this course and being able to talk about the project during this course. With the head of our research at IBM, the motivations are a little bit different, right? So we know that the industry is being moved more and more to statistical methods, and people. Once I heard that once from a guy in Google that says that the main motivation for that is very simple. So the architecture, the whole architecture could be moved from research to product much faster. And he's right in the sense of you just need a linear algebra library, right? And you have your model, you train in the research group, and then you just release that model for a product team, and he just had to run the model, right? So in terms of architecture, everything turned to be very easy, very simple. And this is one of the reasons that the industry is using more and more the statistical methods for many things. But you have to remember the roots and the fact that at some point people are kind of touch on the local optimum, right? And without more information, will not be able to move on to actually break barriers to a real comprehension of language, right? And I think that many people in the company are already aware of that. And IBM has a long-term history on NLP, right? So we are not, these are not something new for IBM. We have many textbooks that when you close a look for the authors, you see that the book came from IBM research. And this is a long traditional. I think in 2011, the Jeopardy competition was a break point. If you look for the publications in the area, many of the amount of publications increased in kind of a correlation with these facts. So I think that that achievement in 2011 bring more interesting to NLP in general. And it's nice to choose, if you guys have a chance to look on the articles that was wrote about the IBM Watson at that time. Behind the code, the main part of the code is a grammar, not a statistical parser. English is a lot grammar implemented inside IBM. I have a chance to work on this code. I have a chance to talk with the author of this code. Unfortunately, it's not a community-driven process. It's just a work of two people, and this guy got retired, and then the maintainer of this code is very hard. The code was over time very optimized to the game to win the competition. So we have many if and else's inside of the code, and the generalization for different language ended up not to be so easy. And in that moment, I started to have the connection with HPSG framework, and that driven me to HPSG. One important thing, I think that I have to be more fast, but one important thing here is that the creation of resources to train the statistical system. This is one of the real motivation that I have, right? So maintaining, I am one of the main maintainers of three corpora in Portuguese in the UD, the BOSC, the GSD, and the PUD corpora, and we are about to release a new corpora, the HBB corpus. And maintain those over time. I learned how difficult it is to maintain the consistency and the accuracy of those corpora, and this is the main motivation to come to a grammar, because the way that the people in grammars deal with the tree banks are much more elegant in some sense, and I can talk more about this later on. And finally, so using grammars to produce lexical resource to be used eventually to train systems, that's a real motivation for me as an IBM researcher. And last thing is grammar engineers versus data annotation, right? So we are doing data annotation, we have all these problems that I mentioned. When you're doing grammar engineer, I think that we are actually coding is very correlated with software engineering, right? And I keep thinking that over time, there is nothing that should potentially block us to think that all the evolution that we have in software engineers should help us to have also some evolution and performance improvement in the grammar engineer side. Performance in the sense of being able to deliver grammars, implement a grammar, and having a general robust grammar in short term. I tend to think, I like to think that this is just a problem as software engineer that we should address, right? We should try to keep developing tools, formalism, and techniques to be able to do that, not just take this as people usually say, right, that this is a hard test for a PhD student and that will never scale. I don't think so. I think that it could potentially scale if you keep it working with this goal, right? Okay, a little bit more about the data-driven, knowledge-driven. That's something from the beginning that I want to test and use, right? Because I started with the data science. So my first project I was studying, my PhD was in logic, as I said, doing description logic and proof system for description logic. And then I started to work with natural language. And one of the things that I did was the WordNet for Portuguese. That was one of my initial projects and the one that I keep maintaining. The Portuguese project, the Portuguese WordNet is a very stable project. We use it even for Google Translation. And this is data, right? And then with Leonel, we developed MorphoBR. Later on, I started to collaborate with UD3 banks. So my history was in lexical in language resources, right? So when I start the grammar from the beginning, we thought, okay, how can we reuse those resources to accelerate the process of construct the grammar? And actually, I will talk about the things that we already did about this. And as I said, we have also the grammar engineer side. So one of the things that I hope to show here is the ecosystem around HPSG, right? The matrix project, the tool called the linguistic knowledge building, the LKB system, the aggregation project, the test, the way that people do tree banking, right? The test suites, the FFTB, and this kind of, all these tools form what I call the ecosystem around HPSG. I don't think that I will introduce anything new for this community. People here are very well educated on those subjects, the complexity of language and the trade-offs between depth and scope, right? So in the data-driven method with corporate and training statistical parsing, we may be able to have a good coverage. But on the other hand, we may not really understood the phenomena, right? And the parser will not be aware of, for example, the fact that some verbs are subject control, and other verbs are object control, and on those phenomena should be handled carefully, right? And this is the trade-off, right? That we're always dealing with language, right? We want a depth, or we want robustness in the sense of being able to pass everything. And some of this, in some projects that I participate, like the project that we have with oil and gas industry, sometimes I have a situation where I prefer to have no analysis, right? A system that tells me I'm not able to analyze this sentence is better than have a system that gives me a complete no-sense tree. Right? Okay, talk a little more about the Delphi Consortium. So the Delphi was a consortium among many universities. I think I have a link here. Let me check. Yeah, I can link here. So this link is public. We are now moving all our infrastructure to GitHub. So this is the wiki that we have been maintained. This wiki was maintained by this consortium for years, and this is a starting point for any question that you have about HPSG and in particular Delphi. And what is this consortium about? So this consortium is about, this is a connection of all those universities. So we have people from US, Europe, and Japan, and across the globe. And this consortium is about two things, right? So they all agree on working with HPSG. So it's centered around the idea of grammars in HPSG formalisms, and also the minimal recursive semantics as the formalism for semantic representation. Yeah, this work from encode state, right? And all derivations from MLRS. And I will talk more, give examples about this, but the consortium is mainly about this, right? Grammars based on HPSG and the formalism MLRS. And all these universities also agree on make all data and all tools open source. I think this is the most active community around the HPSG formalism nowadays. I'm proud to be part of that. So this is just example of things that you have out of the tools that Delphi provides, right? So give a sentence like this. I don't know if you guys are many people, when I show this sentence, remember from where it came from, and this is part of a SIC corpus, a corpus of text entailment, right? And we have so using tools from Delphi, we're able to produce the derivation tree. So this is the obvious first step, right? The derivation tree. But the parser usually, the AC parser usually give us, if we don't ask for the derivation tree, the full action is to give us the semantic representation. So this is the MRS, the minimal recursive semantics. So this is a formalism that encodes the semantic of the sentence is a set of predicates. So you have a bag of predicates here, right? And those predicates are connected among them with arguments. We have the notion of the roles and the labels that address the issues of scope, of quantifiers, of negations, right? We have constraints of the relations of those those roles and labels. And we also have some morphostatic information encoded as on the variables, right? So person, num, or encoded in the variable x3 in this case. From MRS, we can derive many other formalisms. For example, we have here a DMRS. So the DMRS is a bilexical representation. So we have a more direct correspondence between the tokens and the predicates. We still have some predicates that are abstracts in the sense of not occurring in the surface form, like this one or this one. But the main difference between this and this is here we have a completely variable free representation, right? So instead of working with variables to connect the arguments, here we have a graph, just links connecting the components. From the Europe groups, we also have other derivations. So from DMRS, we can also produce a EDS. The EDS is very similar to DMRS, but we have few differences on the EDS and DMRS. We have this DM that's also very close to DMRS, and we also have the syntax tree. So we have the derivation tree that kind of expose the rules of the grammar that we're using during the process of the parsing, but here we just have the constituent tree. So these are all tools that we came from this consortium, right? But one of the main tools that we used in our project is the matrix. So the matrix is a project from Emily Binder from University of Washington. And the idea of the matrix is that you have a questionnaire in a web, in a way of a web form. And you fill this questionnaire, we fill them with answers that a linguistic person like Leonel, for example, was able to do and answer questions of the questionnaire. And once he answered these questions, these answers were saved in what they call the choice files. And the choice files, so the system validates these choice files. So for example, if you answer something in one form that is inconsistent with another answer that you give in previous form, so we have a few validations work on that. And once you have a consistent choice file, the system could generate a grammar for you. So it produces a skeleton of the grammar, right? So so big work on you're not start from scratch, right? And once you have it, and this is done in a way that we have a core grammar that could be thinking about a universal grammar, or that could be similar to the resource grammar from this community, right? So you have these core ideas of a universal grammar, and you have the customization that came from choice libraries, right? Eventually, you have also your tree banks and test sets, and then you can customize the grammar. And later on, you can even customize it directly in the code, right? And I will show examples of that. So that means that we have this diagram, right? Your grammar came from the grammar matrix, and the HPSG theory is somehow encoded also in the matrix and unifying your final grammar, right? So what the grammar matrix is doing is kind of helping you to, from your linguistic knowledge, encode that in the HPSG formalism, in the definitions and in the way that the HPSG formalism suggests to model the language, right? One of the most important thing to call the attention is the fact that behind the formalism, what we have is the type feature structure, right? So this is the unification grammar, and this is based on the idea of type feature structure. So a type feature structure is a kind of a matrix-like structure, recursive. So a feature structure has fields has values. Values could be another feature structure, and has a type. Right. And types allows us to encode and propagate information as any object-oriented language, right? So we have the notion of hierarchy, and so we have things like, for example, in our grammar, we have the hierarchy of adjectives model driven by the morphology of the adjectives. So in the case of adjectives, you have uniform, non-uniform, inflection ones, non-inflection ones, and then we can derive all the feminines and diminutives, and then from this hierarchy we kind of we have these in the bottom of the tree, we have concrete specification of the features that are supposed to have in that particular leaf, but we also have the propagation of the information from the top that is kind of considered unspecified in some sense. So the more you go on top of the tree, you have the more unspecified information that you later on specialize for specific situation. And this is showing here how good it is to model the lexic of the language. And here is just a screenshot of the book. That's a practical book on how to construct language in this formalism using the LKB system. Here's a screenshot of I'm showing here the LKB system. So usually what we have is this is the grammar file, right? I don't know if I hope that it's not too small. I hope that you guys can see the screen. But you have here the grammar was loaded. Then we have the hierarchy of the types listed here. We can click on right click on any node in this tree, and then you can see the definition in terms of the TDL formalism, right? Those type feature structures, and you can expand. You also can click here and look for the complete expanded definition. And what I mean by the expanded is, okay, let's consider not just the local definition, but all things that I got from the hierarchy, right, from parents of this definition. And then if I click in the expanded, I'm showing here that a singular noun, for example, get information for all these nodes in the path up to the top, right? And this is the complete expanded definition if I take into consideration the hierarchy, not only the local information that I have. And here I'm just showing the source files, right? So usually what we have is this people work on source files, load in the LKB and be able to browse the definitions and test the definitions. And as I said, in our work, what we are doing is mostly using the matrix forms. Just to give an example of the matrix form, let's see if I have it open here. I think I have it open. Yeah, this is this one. So this is an example of the form. So this is the matrix form filled with information for Portuguese. So you can expand the section. We'll click here and change the names of the definitions and rules. And then we save the form, and then we have the choice files and can save it and create the grammar for you. Okay. I think that I can move quickly now about this grammar engineer part. So we all know that, right? So this workflow in the grammar engineer, we start, we implement the grammar, you are driven by a test suite that we have some examples of sentences that we expect to parse, some others that we expect to not over-generate. And then we have this whole cycle of doing tests, having some result of the test, check the over-generation or the non-parsed, expected parsed, but non-parsed sentence, and then go back to the grammar and check it. Our goals in the project are, in short terms, we have at least 2 test suites, the MRS test suite and the CSLI test suite, both test suites that in English that we translate one of those to Portuguese, the other one we will translate it to, and then we hope to have these 2 test suites covered in short term, 6 months. Leonel is doing a postdoc here in Rio de Janeiro in the FGV with me, and we hope to have until the end of this year at least those part suites done. In the medium terms, in 10 months or 1 year, we want to have some syntactic annotation of a subset of the corpora, the HPSG corpora, the Brazilian History Biographical Dictionary. This is a corpora that we have in FGV. It's a kind of an encyclopedia corpus with politicians, the history of politicians in Brazil since 1930. So we have all the history of the politician, when the guy was born, the education, the parents, and his life in the politics. So and the idea is to transform this in a corpus, right? And being able to pass some subset of those would be a proof of coverage for our grammar. And long-term project, more than 3 or more years. I think this process is not short term anyhow. So in long term, we want to keep increasing the coverage of the grammar and being able to actually parse unrestricted text. We do have examples of robust grammars like the ERG grammar for English, right? It's robust enough to parse 86–90% of the sentences of Wikipedia, for example. The fragments of English Wikipedia that they took from 2016, I think. So it's a very robust grammar to pass unrestricted text. And if they did it for English, I think we can do it for Portuguese. Even in domain-specific text, I started to use English resource grammar, and I was able to keep passing 9% of the sentence in oil and gas corporate, for example. Using test suite and translate the test suite to Portuguese brings us some challenge, right? So, for example, we have phenomena that when we translate, we have a more complicated structure that we had in the original sentence. So, for example, here, wandering in English is realized as a reflexive particle attached to a verb. So, Abraham perguntou-se se o gato latiu. So we have an extra complexity in the structure of the translation, right? And we also have the case of once we start to introduce this reflexive particle, we also have to think about constructions that in Portuguese we have the agreement between the subject and the reflexive particle, right? So eu perguntei-me. So me is in agreement with eu. Right, and you already have in our grammar the ability to pass all these structures, all these phenomena, right? And some of them are far from trivial if you think about toy grammars and think that we are. I mean, at this point we already cover interesting structures from Portuguese. Trying to move fast because I spent too much time in the introductions and in the motivations. So we have a first paper that we submit to this special issue in the LREC review about Portuguese processing. And this paper is mainly about as I said, the use of MorphoBR and use of UD Corpora to help us to accelerate the development of our grammar. So what we did basically was the following. We compared the MorphoBR, our full form lexicon, with UD. That was the first step. And we did that because we know that both resources could contain some mistakes. And we want to cross-check that, right? So we transformed our full form lexicon, we transformed into feature structures, and then you transform the tokens in UD also in feature structures, and then we can use unification to check if we do have a unification among the token and the entry in the lexicon. Whenever we don't have unification, we list all possible all failures in the unification. And from these failures we learn a lot, right? We learn situations where, for example, in the lexicon, we took the understanding that words, nouns, doesn't inflect in gender an inherent properties of the noun, but in the corpus we found situations where they inflected. We have the compounds, many compounds missing in our lexical resource. We have the new orthographic agreement. So we have the corpus contains text from the previous from the orthographic agreement. We have new orthographic agreement. Tokenization issues, difference between the corpus and the formalization, and also the productive derivations, like the cases where we have in the corpus an adjective being used as a noun or a verb being used as adjective, and how to deal with that in general. The ways to treat those situations are a little bit different between the corpus, the way that we want to do in the grammar, and the way that was in the dictionary, right? Here I'm showing just examples of our dictionary, the way that our full form dictionary is encoded. So we have the inflected forms, we have the lemma, and we have the tags. So here, for example, alegre means happy, simples means simple, and corremos is we run or we ran, right? So here's for example, simples is an example of an adjective that doesn't inflect in number, not even in gender. But we have cases where we have inflection in number, but not in gender. Okay, so those are the examples that I mentioned. One thing that also happened is this lack of information in UD formalism regarding, for example, of diminutive and augmentatives. It's so UD doesn't actually handle that. He has a feature for degree of comparison that's usually attached to adjectives, but this is not exactly what you mean by augmentatives and diminutives, right? Augmentatives and diminutives. So this is one of the things that I raised that issue in the UD documentation, and people start to discuss approach for that. We have at least one language that actually solved that with one extra feature. But we just, I think that's a nice thing is that the paper contribute with this discussion, right? For okay, how you can spend it formally to deal with that situation, right? And on the other hand, we also have the degrees of comparison that UD has. In Portuguese, they are not very productive, right? So in Portuguese, these superlatives and comparatives, they are usually encoded as more than one words, so they are not morphologically encoded. And we have few cases where we have morphological coding for that. So in our dictionary, we actually encode that forms as any words. Okay, so after consolidation, so after we finish that consolidation, we start to model that, use this dictionary to model our lexicon in the grammar, right? And the idea is that we actually fill the form of matrix, encode the hierarchy of the adjectives. In the case of the adjectives, we follow, as I said, the hierarchy was a kind of a match with the morphology, the idea of facts of the morphology. That was not the case for verbs, but for the adjectives, we follow the hierarchy is a modeling of the based on inflection. And then once we have the rules of the morphology, we actually just fill the elements from the dictionary into the grammar. And we tested this. The basic work was to find the regular forms and the irregular forms and treat them separately, because in HPSG we deal with that in two ways. So we have a way to encode the morphotactics of the morphotactics, but we also have to deal with the irregular forms, and the irregular forms are listed explicitly in a file, and we have so the work was that, right? We have to check the dictionary, identify if we are dealing with regular or irregular, and fill the appropriate parts. I'm moving a little bit fast just because of the time. Then we have this discussion about, okay, so there are some limitations about what we can encode in the dictionary, what we can encode in the formalism itself, right? There are, so in the questionnaire we just encoded morphotactics. We don't have expressivity to encode anymore. In the formalism itself, Leonel was able to actually write more rules and to alternations, morphological alternations. So in a situation where we want to actually change a suffix for another suffix, but we still don't have the full power of a finite morphology with transducers, right? I have to skip a more deep discussion on that because of the time. But just giving examples, this is a kind of rule that was encoded manually in the system, and this is able to deal with all this example here, right? So this is the rules for construct the feminine, the feminine inflections of adverbs, of adjectives, and we also have the irregular forms written in another file. So this is the irregular forms that are encoded here. So as you can see, for example, trabalhador do have an irregular form. Okay, so this is the hierarchy that we have for adjectives for now. As I said, this hierarchy is behind that hierarchy. We have a propagation of information from the top to the bottom. Here is an example of an analysis of one particular word. So felizõezinhos is a particular interesting example because we have diminutive, but also an augmentative, and they are together. and also plural mark. So all of these things are encoded as features here associated to that particular sign, that particular word. Okay. So as I said before, right? So once we have we want to produce these in tree automatically. That was the work that we reported in the paper, right? So during the lexicon, we found the regular form, and from the regular form, we check how we check the regularity. We check these rules here, and we see if our full form lexicon from the inflected form, from the lemma form, we check if there is a rule that covers that inflection. If there is a rule that covers that inflection, we consider that regular. So the rules that Lionel encoded was the guide for identifying the regular versus irregular forms. And once we have this information, we can just populate automatically the lexicon of the grammar. And this is an example of the of lexicon trees in the grammar. As you can see, we are kind of automatically adding the type information. So the way that we read this formalism is, okay, feliz is in tree of the lexicon that has this stem, feliz, the surface form, and this is a subtype of the uniform adjective lexicon with this extra information. So think as this E here and saying that, okay, add to this type this extra information. So these together is a new thing that have all the concepts associated to that, all the properties associated to that with those extra properties. Right. Okay, so there are limitations, as I said, in the way that morphology is handled in LKB, and there are ways to overcome that. So the finite state morphology using, for example, translucent, we can do more things that we are able to do in the LKB itself or in the matrix forms, but and people have different solutions for that. So far, we are finding our ways in the current limitations. I will not have to take time to go into deep on that, but another way is to plug some pre-processing tools. Like even the English grammar has a pre-process that are able to, for example, make a first analysis tokenization, or even some kind of the Spanish grammar, I think, use a system that makes all the morphology analysis first before start the grammar processing. We did an evaluation of the paper, and basically we reported the check that we did to check if our process, if our algorithms were following what we expected, and we were able to show that for using the extra rules that Lionel was able to encode, we were able to encode for our test sets. We produce a simple test set, but from patterns we produce sentences, and we are able to parse 87% of the sentence, and then we are able to find the mistakes of the algorithm. Actually, this work, as you should expect, is not only about the grammar itself, but also to improve the resource, the source resource, the morphobehavior resource itself, right? So during this process, we learned a lot about the mistakes that we have in the resource, and we plan to fix. If you go to the morphobehavior repository nowadays, you'll see that we have a bunch of open issues, and some of them was created during this process. We found issues that we need to fix in the resource. Okay, and next, what we have next in terms of development. So the current state that we have all the morphology encoded, so verbs, nouns, adjectives, and determinants, and we are driven by as I said, by the test suites phenomena. The hierarchy of nouns is here. Not very surprising. The hierarchy of verbs is a little bit more interesting because it's not based on morphology, but it's based on the valence of the verbs, right? And the valence is something that we are now studying, right? What would be the resource that we can use to populate the hierarchy of the verbs? Because our morphobehavior is does not have information about the valence of the verbs, just about the morphology, right? And then we have to add one extra resource to that. But that's our next work. But at least the hierarchy was already modeled, right? So you have for example, cases like verbs that has clausal complements and all these cases of clausal complements. We have extra limitations regarding the clauses that are headed by the prepositions, and then we have to specialize these prepositions used to head the clause. I think I'll have time to do that. We have this case of finite clause, we have an infinite clause, and examples like this one here. So these hierarchy of the verbs already modeled. This is the what I just mentioned, right? So we have in Portuguese situations like this, em que. So verbs that are ask for a clause to be introduced by a preposition. So insistiu em. So we needed this. I didn't put the translation here. I'm sorry. So the dog insisted to the cat to sleep, or he insisted on the trip. In Portuguese, you have the contraction, and this contraction is actually en. So it's a preposition followed by an article. So it's the same, the verb insistir asks for this preposition. So we have to model these situations, and that's why we have this specialization here, situation that we have a verb that asks for a preposition. On the other hand, we have the key part that is the head of the clause. So we have this solution for having these composite complementaries to the clauses. This is the solution that we have so far to model these two demands from the verb and from the clause. In Portuguese, you also have, actually, this problem was solved. During the process, we are kind of a contribute back to the matrix system itself. So one of the things that we found is that in Portuguese, we have this phenomenon of some verbs like quer, wants, right? We have these volative verbs that require a subjunctive mode, right? So o cachorro quer que o gato late is ungrammatical, but o cachorro quer que o gato lata. So the dog wants that the cat bark. So we have this asking. So the verb here in the second clause, it has to be in a specific mode because of this verb. Right. So in declarative verbs like declarou, afirmou, declare, or what would be the translation to affirmou, state, right? Ask for is under ask for indicative mode. So declarou que o gato late, and not declarou que o gato lata in this subject form. So this requirement about the particular verbs requiring a specific mode in the complement clause, we didn't find in the form of the matrix the right way to encode that. So the solution that Lionel ended up doing is that once we didn't find the ability to specify that, we specialize directly in the code, right? And he modeled that in the code. But end up that during the meeting that we had last week with the Delphi community, we ended up identifying that actually the form was able to encode that, but the way to encode the thing was not clear in the form. And then we have to refine our process, right? We remove this specialization, go the form and declare in the right place of the form. We have to declare the first thing. I'm just saying that because it's interesting to have this notion of how things evolve and how people are open to this contribution, and actually how they help us to actually make the grammar and keeping evolve on that. And we also found many other limitations that we are about to discuss with these guys. So in the matrix form, it's not clear for us how to model trivalent verbs. The case of subject raising, right? In complemented clause. So I ask who is sleeping. So we have this situation where quem está dormindo. So in the main clause, we have this está dormindo, right? So the point here is that the subject of estar is the subject of dormindo. There is a raise between these two verbs. And in the main clause, we are able to model this situation, but in the complementary clause, we have some limitation on model those phenomena. A similar situation for object control, and as I said before, how to handle these complementizers situation like the compound complementizers that I just described. Two more limitations. we have situations in Portuguese like a verb, like obedeceu, obeyed, is by transitive, as a transitive verb, right? But ask for a preposition, and you have to be able to deal with that. So far, we're not able to deal with that. And finally, matrix, it doesn't handle punctuation. So sentence like o cachorro está dormindo is underspecified as a question or proposition, because you can think about the dog is sleeping. In Portuguese, you can have this, it could be depends on the way that you say the word, the sentence, it can be a question or it can be a statement, right? An affirmative statement. But we do have situation where we have a specific clue, a specific word that marks the question. So in that particular situation, now we have a full information to produce a semantic with the question tag, right? So será que o cachorro está dormindo? Is the dog sleeping? Is clear, a mark for question. Final slide, sorry for being late. Robustness, right? So in the long term, we want to be robust, and there are many tools that these guys in Delphi develop over years to actually address robustness, right? Because most of the projects that those guys have are in real projects with processing unrestricted text. So tools that we want to explore for Portuguese is all the pre-processing tools, like they have a formalism for regular expressions, formalisms just to deal with tokenizations and to guarantee that you have the right tokenization for the grammar. And this tool is able also to add some extra. They have a mini grammar with special tokens that it can add, for example, to for example, add limits between phrases. And this helps the grammar to reduce the space of search during the chat parsing, because it's not, it will not break the phrase into two different phrases. So this pre-processing tool is very important in the ecosystem of HPSG. Post-tagger for generic entries. So the English grammar use this a lot. So it has a post-tagger that deals with words that are out of the vocabulary of the grammar. So they just introduce an item in the lexicon if that item has some specialities that have justified the introduction to actually guarantee that the analysis will always be in that way. But otherwise, he could have the post-process working. And when I use the English grammar for processing in project that I mentioned, the oil and gas, that was unbelievable useful to deal with all terminology from oil and gas. Nowadays, actually, the things is changing because the author of English Resource Grammar, Dan Flinger, he's had this project to actually now relax on his restriction about the lexicon of the English grammar. So he told me that he wants to have all the lexicon of the English WordNet inside the grammar. So he wants to guarantee that all the lexicon of WordNet inside the grammar. Lexicon threads and many other techniques that they produce to be more not only robust but performance improvements on processing the grammar. Tree banking and max entropy models. Tree banking, we kind of start with simple text files and marks of oh, this is grammatical, this is ungrammatical, but we have to evolve. They have tools for tree banking, right? And these tree bankers use the idea of profiles. So we have the test set, but we encode also all the information about the parsing process, how much resource was done, how much edge was created, and those things are important to the grammar engineer, right? Because it's not only about parse or not parse, it's also about, oh, how many derivations I got. There are suspicious derivation here. Can I change the grammar to not derive things that are not necessary in this particular situation because it's suspect to have just one derivation? or many other performance informations about the grammar are able to do that. And then we can encode the version of the grammar that produce those derivations. And then we can compare different versions of the grammar. Oh, in this version, I had those statistics about the analysis. In this new version, I have this difference, and we can compare that. So the tool set around this is very useful. And actually, Leonel already identified that we start to need to dig into that. The max entropy model is just a best ranking, right? So inside this ecosystem, we do have the parsers are able to, using the tree bank, we can actually, once I have a grammar, we can give a text, we can tree bank the text, and then if the way that we do that is using a tool that exposes to us the rules of the grammar, and then even a sentence, we just have to select the options that the grammars allow you to do. Unfortunately, I didn't have time here to present this tool, but it's a very nice tool. Sometimes we have a sentence with 1,000 analyses, and then in 3 clicks, we are able to disambiguate and produce the final analysis much faster than doing a tree bank. Actually, people at IBM was impressed by that. I was able to annotate 2,000 sentences in 2 days. It's amazing. And once you have those disambiguate, manually disambiguated with the rules of the grammar, the tools was trained with what they call these decisions that you make, right? They use those decisions to train the model to parse selection, and then we have the parse ranking, right? And this is, of course, when the grammar starts to be robust, we need to do that, right? Okay, sorry, I think I've used more time than I expect to use. I'm sorry for that, but I hope that you guys take something from the presentation. Open for questions.
Thank you. Arne has a question, so let's go ahead and ask.
Yeah, I'm sorry, I also have to leave in about 5 minutes, but thanks for this insight into working on the grammar matrix. And I would have many questions, but let's just have some of them. So I remember when we started GF, so then you had these grand grammar formalisms like HPSG and LFG at the time. So and they were very much geared to parsing, right? And whereas GF was kind of profiled as a generation grammar formalism. And I wonder, so, and I never really saw clearly how does HPSG, what does it give for natural language generation, or how can it be used there? That's my first question. And then the second question is, so since you have this Portuguese resource grammar that Bruno made, so have you been able to reuse some information from that when building the HPSG grammar?
Okay, nice. Two very good questions. So I would say I was almost trying to do a quick demo here about the translation generation, but I will save that time because you said that you don't have time and don't want to waste more time from people. But basically, yes. So the grammar are bidirectional. So all the grammars can generate and parse. And actually, the history behind the Delphi community is very nice because they started with translation projects. And they have a very robust system to make translations. So the idea is that we got the parser, you produce the MRSs, and then they develop a special tool that actually using the same formalism, the TDL and the unification, they encode rules to translate semantic structures. And then when we have the final semantic structure, then we can serialize that back, because taking the advance of the fact that all grammars are bidirectional by definition. Mm-hmm. And we have a recent PhD thesis from Michael Goodman that actually kind of modernize this whole tool set He implemented a very nice Python library that's called PyDelphi that has many tools to manipulate TDR files and grammars and those kinds of things, and call the parse and stuff. And on top of that, he made a very good discussion about modernizations over this traditional way to encode rules to transform a semantic structure. But he basically put on top of that some statistical component that it could potentially be able to learn those rules to translate semantic structure. But the quick answer is all grammars are bidirectional by definition, because we can go from the parser to the semantic structure and the semantic structure to the parser. And given that we have extra tools around this ecosystem that deals with transformation of the semantic structures. So I think that, and actually inside the repository of English resource grammar, Dan has a very nice project that he developed with a professor of logic in Stanford. They has these, this book of logic that we use the passkey words to let people learn logic with these. We have a matrix of objects and colors and size, and then the students are supposed to write sentences about, oh, there is a triangle on top of a rectangular. There is a blue triangle, a big blue triangle on top of a small rectangular. So this is a very popular book on introduction to logic. And Dan made a project with this guy, and he implemented actually the generalization. So the focus of the project is generalization. He took a logical form, produced MRSs, abstract MRS, put some extra information, linguistic information type, and generate language. And these students are supposed to, the students use those to actually go the other way around, to get to the original formula that are encoded in that natural language. So this project is very nice. I can send you the link of this paper that they wrote about this project. The code is completely free and open there in the repository of English resource grammar. So it's all about generation. Regarding the second question, we did have a lot of insight. So actually, the history behind the MorphoBR repository started during the project of Bruno in the GF for Portuguese. And actually, one of the first tools that we had to work with the GF, Bruno implemented in GF, because he used all the I forgot the terminology, but remember all these papers that I read with him about the way that morphology is encoded in GF, and use that a lot from the beginning. Nowadays, we are not actually actively using that. I'm really open to have more students that wants to get the work from Bruno and keep evolving on that. This is for sure. I will talk about GF in this course that I just started teaching on introduction to NLP. But I have to say that MorphoBR started with Bruno helping us and using GF tool behind that. And sure, we have some insights of errors that we found. MorphoBR was constructed as a combination. We took 3 or 4 other resources from groups from Europe, from Portugal, and from groups from Brazil, and we kind of merged those resources and solved the problems that we found inconsistent between them. And most of this initial work was done with GF by Bruno. And I think there is. I think there is a very strong general interest of avoiding duplicate work when you are working with this knowledge-based language technology. And we have had these GF workshops, the grammar engineering across frameworks. So, but I haven't seen one for some years now. We had one. Well, you should start to make another one. Yeah, right. Maybe, so we organized it with Emily Bender at the time. And, oh, nice. And some others, nice. Yes. Yeah. Yes, I love her. I think that she's another one of the people that I learn a lot, and she's a nice person. So yeah, that's definitely something. One of the things that's important for me, at least, is, and I think for Leonardo too, it's not to take MorphoBR and convert it to HPSG. We want to have MorphoBR as a resource itself, and then, as you said, maybe able to reuse those across different formalisms, across different projects. So I think that's really important. Okay, thanks. Thank you.
My question is also related to, because I remember seeing Bruno's questions on the GF mailing list some years ago when he was doing the same corpus about cats and dogs barking and all these subjunctive imperfect things. Like, would you say, like, maybe this question is also to Bruno himself, so like, is there some, like, are some sentences like easier to parse in this HPSG grammar and harder in GF, or vice versa? Like, or would you say equally easy?
Yeah, that's a very interesting question, and that question I made for Bruno many times, right? Because at some point of the project, you guys know, when we start to act as advisor, but at some point the roles are not. It's kind of a fuzzy, right? Because Bruno started to read much more fast papers about GF than I read. So I introduced him the formalism. I motivated him to work on that. And at some point he knows more than me about this, right? And then I start to make those questions to him, right? So what kind of in the end of his project, I want to have some examples of, okay, let's try to show what we can parse. And one of the things that Bruno keep telling me that there are many limitations regarding for example, these ambiguities, right? So the performance issues and the ability to do those ambiguities, the parsing ranking. So many things that in HPSG and Delphi community, these are very natural because it was created from scratch to deal with the scalability issues, right? So the parsing ranking, for example, is one of the most important things, right? Because I can train the parse to rank the analysis for me and give me most plausible analysis regarding the fact that one given sense can have thousands of possible analyses, right? And that's generally the case. In GF, I give a simple sense, I have many thousands of analyses on that. Lexical ambiguity, many different cases about this ability to deal with real language, right? And Bruno, I don't know how accurate he was, but he convinced me that we have a lot of limitations in GF to handle even the sentence of MRS and the test suite. The sentence of bark, dog, bark, cat, those sentences came from the MRS suite. And even for those sentences who was not able to actually produce to me, convince me that he would be able to parse all of them in his GF grammar. I have to read back.
Checking here, we parsed 101 out of 107 after creating a metric to specific grammar. Yeah.
I didn't know that you're here. Wow.
I came a bit late to the party, but I'm here.
Okay, so you can answer for yourself. What? Sorry, can you say again? What was the number for the MRS test suite? Do you remember?
No, I didn't remember, but I checked 101 out of 107 sentences. We managed to actually parse. And one of the things that I take away from like learning a bit from HPSG from you and having learned GF for my master's is that there's a lot of tooling that HPSG has that GF doesn't have, but it's also true on the contrary, right? For example, there's nothing like GF test for HPSG as far as I know. So it's just, as Arne said, GF is more geared towards generation and HPSG is more geared toward parsing. So it makes sense that the tooling that exists for each formalism is directly related to this specialization of sorts.
Yeah, I one of the regarding the next works around the Bruno results, I have many ideas, right? So the work that I mentioned in previous talk about the gloss tag corpus, right? I think that would naturally fit on something that could be done by GF, for example. I would like to be able to have all the glosses and examples in the gloss of WordNet with completely multi-language, and we now have all this work on trying to have these projects of different WordNet in different languages connected. So I'm part of Global Net Associations, and we are keeping work on this idea of having this resource more aligned. And I have this tentative of now I'm using HPSG for that, but that could potentially have some connection with the work that people are doing of WordNet and GF. I would be very happy to talk about this. The test suites, we can dig more about the results that Bruno just described. I think there are many lessons that you can learn. The tool set that Bruno described, I think that's a very nice comment that he made, because I mean, people could have this two-directional learning, right? So tools that people learn that could be used for GF could be very useful for HPC, and the other way around. The main difference for me is actually not exactly this. Okay, we have this emphasis in parsing or emphasis in generation. I don't think that the HPSG has any emphasis in parsing. Actually, most of the time, if you talk with a grammar person like Emily, he will talk about generation. Many grammar engineers think in generations and talk about over generation. So generation is actually much more natural to them to constrain the grammar than parsing in many cases. But it's more about, there are other things that, for example, the idea of semantic representation. This is something very rooted in HPSG, and we don't naturally have that in GF. So we have the formal representation of the syntax, but we don't have the semantic representation of the sentence. And I think that I raised those questions in the GF main list in the past, right? So how can we, for example, deal with applications that want the semantic representation? I'd like to go from a language to a formal language. And then in GF, you would potentially have to think about the concrete formal language to encode the semantics. But MRS is not a concrete formal language. It's a kind of a meta language to encode semantic that could later on be specialized to first order logic or high order logic, or anyway, linear logic, include semantics from Dick or things like that. So
it's like the semantic layer that's like a built-in feature in this formalism already, whereas in GF you first do a resource grammar, which is completely like application agnostic, and then if you want to do a semantics inspired application, then you can use this library. But is that yeah. I have some more questions, but if anyone else has one, please go ahead.
Thank you, Bruno, for being here and for complete any misinformation that could have started to give.
No problem.
Okay, yeah, if you have a question, just interrupt me or raise your hand. So I have, so I'm thinking from a perspective of if someone is watching this who doesn't know GF, doesn't know HPSG, like is trying to make up their mind, should I write my grammar in one of those or in something else? So this is the perspective from which I'm asking my questions. So
what would be my answer? Your question is what would be my answer?
Yeah, no. Well, I have more specific questions as well. So okay, so I noticed like. So okay, I noticed in the slide that you have up right now, you say that you talk about limitations, saying that the questionnaire doesn't support the implementation of a verb taking its object, introducing the object by preposition. And coming from GF world, that seems kind of extremely strange to me, because like that's like the super basic thing. We can totally do that. And like even like so this, even though RGL has a common core, like as Bruno said, like he just made some extensions until most of that test set was passed, and those extensions were Portuguese specific, and that was, you're not supposed to have that function for other languages, or maybe for other Romance languages. But so like it seems like from my side, it seems like okay, so this would totally not be a restriction in GF. So can you explain a bit more? Why is that such a problem there?
Okay, so I think that we have to take into consideration that, first of all, I'm not talking about limitation of the HPSG formalism. I'm talking about the limitation of matrix system. So the matrix system is an evolving system, right? It's a project for Emil Bender. It's funny because even the Delphi community, when I started to join the meetings that they have, and now I'm considering myself as a member of the Delphi community, but it's funny because the matrix project was not listed in the wiki of the Delphi community. It's something that is actually the core of Delphi Consortium product, because it's mainly a project from Emil Magnet. As he's a grammarian, and he uses that in his course that she teach every year in the Washington University. And over time, with different students contribute with different models of the system, and the system keep evolving, right? So this limitation could seem like, well, this is a ridiculous limitation, but this is a limitation of the form system. So we can always overcome that limitation with some specificities in the code, right? You can just specialize. So you take a type there, and then you specialize a rule in the TDL files, and then you say, okay, we did that, for example, even for, let me see if I can show. I'm not
so is
sure
that is that analogous to the fact that, okay, maybe some of these constructions were not available in the RTL core, but then Bruno added some Portuguese specific extensions. So
exactly.
Yeah.
This is the same analysis. So the matrix is a system just to because you have to think like a feature structure on HPSG. Over time, those feature structures, then the model of the basic components on top of the hierarchy, those are really complicated, because over time these evolve a lot on handle different kind of agreement and restrictions of verbs and kind of thing, and how those propagate over the sentence. So these things could be complex, right? And having to start from scratch to produce that would be a nightmare. But if you do have a matrix that produces everything for you, then the specialization is very simple. So the case that I was about to show here is that, for example, the questionnaire gives us things like this, right? So when Leonel filled the questionnaire, we have very rules with just one rewriting rule here, saying that the way that handle the suffix. And then Leonel go there and specialize that rule, putting more information, much more rules to that particular, So this is a kind of customization. We took a type already defined in the framework, in the questionnaire, the type with the right position in the hierarchy. So everything was modeled in questionnaire, and then we specialize only the rules, and we specialize the way that this type was actually implemented, right? So it's kind of analogy to have an IDE to Java code that you kind of work on the class structure, define interface in this thing, and then at some point you click and then write the actual Java code to the method, right? So this is the same thing here. So I think this limitation here is more about the matrix, not the formalism. For sure, the formalism is able to deal with those constructions. I don't have any doubt about this.
So you didn't do it yet, basically.
Yeah. And the final word is that the limits between what they want to add in the matrix and what they want to have as special cases to do with the grammar, in the particular grammar, this is again a little bit fuzzy, right? It's not clear. Last week, for example, we have this discussion. One thing that a question that I made, Emily said, "Oh, maybe this is something very particular you should do in your file." And one of her students said the opposite. Oh no, I think that's could be encoded in the form. So I think that people are still debating about what should be in the matrix, what should be in the specific. There are not only limitations about they didn't encode in the form because they didn't have time. They can have limitations about what is the place to put that.
Yeah, obviously, it's always a trade-off. Leonard wants to ask a question.
Yeah. I think a comment probably. You want to add something now?
I would just like to add information that how the questionnaire was constructed. Each practically each page or each group
of have pages. A lot of noise. We can hear you very well because we have a lot of noise in the background.
Okay.
It's better now, I think. Sorry. Oops.
So can you hear me now?
It's better.
No. Can you hear me now?
Yes, we can hear you.
Yes.
Okay. I was just saying that I would like to explain how the customization questionnaire was constructed. Practically each page representing a grammatical phenomena represents the work of a student who did this research as part of his or her dissertation or master's thesis. So, how did these people work? They researched the typology literature about the phenomenon. For example, how core arguments are encoded in the words' languages, and they build a sample of languages which are representative but are not exhaustive, and they create the customization questionnaire with the questions that are to be elicited to get the answers about how each language is encodes this phenomenon. And then the code, the TDL code, the HPSG code for each language is constructed. So it is expected that some phenomena are not covered because the sample is not universal. Yes.
Of course, yes, I understand. So I think, yeah. So I
was trying to make a visual illustration of what Leonel was saying, right? So if you guys follow my screen, I show that we have on the top of the form each questionnaire here on the top on the right hand side goes to a form, and this form has a documentation on the top. So for example, the form that talks about tense and aspect, I have this documentation on the top, you have the form, and then the documentation points us to a place where probably the student that implemented this model and this questionnaire documented his work and how he chose to make this thing, how to choose to model, and this was end up in that thesis or master thesis or PhD thesis, and this was over the years. And the paper and the workflow that Leonel just described was actually documented in the paper from Banner, right, Leonel? You mentioned that, right?
Yes,
how he expects to have this workflow, core models, and customization of questionnaire, and how people could contribute to the matrix and stuff. And I think that's an interesting thing, because there are lessons to learn here from the maintenance of the resource grammar in the GF.
Yeah, exactly. I mean, that would be very cool to customize it for, like, do the questionnaire and then it would generate the link, gets on the params and some kind of dummy implementations. There are many modules in the resource grammar, so it's
exactly.
What is important to emphasize about the questionnaire is that it enables people without no knowledge of the formalism to build a starter grammar, a grammar which is already a middle-sized grammar. And it's amazing because in 6 months you can fill out all the pages of the questionnaire, and you have shown you have already a relatively big grammar, which produces very complex representations without any knowledge of the underlying code. And I know that the code, but it's more practical to fill out the questionnaire because it represents lower work, a lower amount of work. Yes.
Yeah, that's definitely a tool. It would be cool to have in GF. Like, it would be someone's cool project. No?
Yeah.
Any more questions? It's kind of late in Singapore. It's kind of time to go to sleep for me.
Okay, I'm so sorry for, I'm sorry for taking too long time.
No, but we started 17 minutes late. That was like completely expected.
Okay, that was great. I said thank you very much for all the hard work that you are doing to put this event in place and organize everything. And thank you for the invitation. It's a pleasure to join this community.
Yeah, maybe you can organize the next GF summer school or this grammar engineering workshop. Or who knows?
Yeah, something that yeah, make total sense. And yeah, let's talk about this.
I would be very happy to fly to Brazil or whenever that's possible.
I hope for next year, I hope that life will return to the normal ways.
Yeah.
Okay, thank you.